mammals which could not. You know, the only other animal which would develop, which could break down cellulose is the one I'm about to talk about. Now, the impact of sauropods on what was essentially an era where in the Jurassic Age, where forest dominated around the coastal lands inward of about 1,000 miles, which is about roughly of what we see now in terms of all the continents being part of one supercontinent, Pangaea, and there being massive deserts and arid regions where very little, if anything, lived. Maybe maybe solitary insects, because at this stage you don't have social insects, which is the creature that I'm about to talk about. The impact of sauropods on the forests, of course, must have been great, because unless you're having very few sauropods, and they're having to eat many kilos of vegetation and move great distances, never staying in one place, it means that the drive to get bigger is not only rapid, it is an absolute necessity, because you need to digest all this bulk of vegetation, because it's very, apart from the cellulose in it, which is difficult to break down in itself, it's not very nutrient rich. Pine needles today are often talked about as having large amounts of vitamin C, but I mean, are those sort of waxy pine needles that an obvious choice for animals? At this stage, herbivores are in a sense predating on plants, and plants are going to do everything in their power to not advertise themselves as a good meal. They're going to try and do a defensive strategy. But something happened around the Cretaceous era which changed everything. If you remember back to the start of my talk in part 1, I was talking about the idea of atoms and particles sharing energy, transferring energy to try and reach a kind of natural balance. I'm not a particle physicist. I'm not in chemistry at a high level, but there is a kind of sharing of energy between different atoms. And you can see this through perhaps if in physical terms, from uranium and plutonium, uranium becoming lead. You're seeing a reduction in radioactivity, which is and radioactivity, of course, is energy lost to other elements. Because you can't destroy energy. So from something so simple as an atom and particles, and also proteins such as prions, which of course famously caused the mad cow disease, and was because different proteins were trying to link together, in a kind of to sort of balance out their energy. It's a complex process. That's basically what is happening. Now, when biological entities such as animals and plants started to try and develop a system which was not based on parasitical predation, either of by herbivores on plants or carnivores on herbivores, something started to fundamentally change. Now, there's evidence that funguses perhaps had this trend to creating a network, and there is some evidence to suggest that there is actually a chemical communication process going on via networks of fungus in the ground with trees in the modern day. We can't be sure whether this actually happened in the past. Before as from the rise of funguses, and I'm not an expert on the rise of fungus as a group. It's not very interesting for many people to look at something which is absolutely profound to me, from seeing a recent BBC programme, which is what has sponsored me, which is what has made me do this video. If sauropods, dinosaurs, had an impact on conifers, and there was an opening, a gap for nature to fill a role, and evolution to fill a role, then at some point in the Cretaceous era, plants began to develop a new kind of system, a system of bribes and of trades, which wasn't dependent on animals completely destroying that plant to get energy. You know, they weren't destroying that plant, and then that plant never had a chance to reproduce and develop. Now, we've already seen that the life is actually, in a sense, terraforming Earth, and changing the climate, changing the weather, and everything else, from the rise of oxygenating plants from photosynthesis, which destroyed many other animals, the rise of DNA before that, and at this point now, the rise of flowering plants, which have nectar, which are drawing energy from the earth and from the sun, and developing a bribe to solitary insects. You can see that if you've ever done any gardening or building work or anything else in the garden, you can see that aphids are might be on your tomato plants. So there are still parasitic animals, but maybe it was that plants co-opted those single insects into being a conveyor of genetic information to another flower of the same species or similar species. In fact, the idea of a species being one group which can't breed with another is very difficult to understand in terms of plants, because plants can actually cross-pollinate in sort of the same way that say dogs and wolves can breed together, which is a point that I'm going to come on to later in this series. So plants are generous with their genetic information, if you want. Flowering plants want to spread it to all the other species. Some were some that have survived are very, very simple leaf structures, which are turned into flowers to attract insects. It's not doing it because it's an aesthetic that humans like. Humans like it to look at these things. You know, you give your girlfriend a bunch of flowers because it's kind of got into us that they are worthwhile as either a food source or a representation of a trade or a commitment to something, you know.